is ugly. You're right. You know the cubic equation, Carnot formula? This is super ugly. It's about 1,000 times uglier than this guy. So those kind of formulas nobody can memorize. So solving that equation for solving for y in terms of x is practically impossible. Now even the second equation, which is this guy right here, you know what? This one we can use in the Kojirai formula, but this one, when you use the Kojirai formula, it will also be ugly too. And especially with this plus minus thing, you don't know exactly what's going on here. And so practically not possible. Okay? So the answer is no. Not possible, not possible, not known means, okay, too ugly. And therefore, the conclusion is, therefore, dx slicing is not possible here. So whether the dx slicing is possible or dy slicing is possible, it is not a matter of how the shape looks like. It's not that. It's an algebraic issue. Dx slicing is possible? It's an algebraic issue. You have to look at the equation. Equations will tell me whether it's possible or not. Equations will tell us if dx slicing is possible, or not possible. Possible. Oops. Okay. Again, which slicing we have to do is a pure algebraic problem. It is not a graphical problem. Even if we see the region will not tell us which slicing is possible. The ultimately possible is what? Well, of course, if you graph it, then of course you know how many intervals we need, so you can determine that. But the absolute whether it's possible or not possible is determined by the equations themselves. Can it solve for y? Can it solve for x? In this case, dy slicing is not possible. So now look at this here. So identify the region. Which lies over since the equation solved for x in terms of y, and now you know what? I don't know why the sigma is over here. I think that's a typo. Yeah, sorry, that's my mistake. So I don't know why the sigma is here. Sorry. Sigmas. Why are the sigmas here? Why? Because when I was writing these notes, what was I doing? I was watching my favorite soccer game, and I was eating my favorite burrito, right? And so when I'm in my favorite burrito and watching a soccer game, I'm not paying attention to what I'm writing on my notes, right? So that's what happened. Anyway, the sigma is out. So again, I didn't put it there because I love the sigma sign. Okay, so cross it out. So cannot be solved for y in terms of x. That means dx slicing is not possible here. So you can only go by dy slices. And now we let x goes this one, call this guy f of y, call this guy g of y. Now what? F of y minus g of y. And if you graph this, you will know which graph is to right or left, and then this, and then y and then we get this. The difference, fy minus y is this right here. Now we have three intersections. We have y plus 1, we have y plus 1, and y plus 0, and y plus negative 1. Yeah, three intersections here. When y is greater than 1, then f of y is actually greater than g of y. And this this region will be an unbounded region. So we are not going to do that. And so now these two cases right here, when x is between 0 and 1, we get a bounded region. And the g of x will be greater than f of y. This is f of y minus 0. And then when x is this, then we get this. Now it switches again to this. And by the way, in this case, I call them here. How do you know whether they change how do you know whether the upper bound and the lower bound change? When? How do you know? How do we know if the right boundary equation and the left boundary equation changes? Yeah. It changes sign. Changes sign. What? Changes sign when crossing intersections of multiplicity 1. Multiplicity of let me call this multiplicity 1 or odd. A multiplicity 1 or multiplicity 1 odd. That is multiplicity what? 1, 3, and 5, and so on. So should I explain to you what that means? Now, if you look at the fx and fy and the goy there, note that each time we cross the board to the next interval, the f and the y, fy and goy, they actually crisscross. Yeah. So when y is greater than 1, when y is greater than 1, then fy is greater than goy. And then now when you cross over y equals 1 to come to the next interval from y when y is 0 to 1, then note that the right boundary and the left boundary changes. And then when you cross over 0, then on this interval now the boundary changes again. And when you cross over -1, then it changes to this again. So how do I know that it's changing or not changing on each of the interval? I know that because every intersection have what I call the multiplicity. So in this case, what we have is x equals what? We have this is first power, and first power, and first power. So what I would like to say is that this intersections, x, so what is it? Y equals 1. This is an intersection of multiplicity 1. Y equals 0. It's an intersection of multiplicity. Multiplicity 1. And then what is this? Let me write the other one too. And what's the other guy? The other guy is what? Y equals -1. Y equals -1. Yes, y equals -1. Is also an intersection of multiplicity 1. Multiplicity 1. And how do I know that the multiplicity is 1? Because the exponents are right here. 1, and then this is 1, and then this is 1. It's like the multiplicity of roots, remember? And so intersections, they have multiplicity too. So if it's a multiplicity 1 intersection, when two curves they cross like this, this is what I call an intersection of multiplicity 1. Intersection of multiplicity intersection of multiplicity 1. Now, how does an intersection of multiplicity 2 look like? Intersection of multiplicity 2, it looks like this. I'll show you. A curve is like this, and then the other curve is going to look like this. And then they intersect right here. But you know what? They don't cross. This kind of intersection is what I call intersection of multiplicity 2. Intersection of multiplicity 2, or even, or higher even. I cannot see clearly here, but that's an intersection of multiplicity 2. So if I look at the multiplicity, you know when the upper boundary and the lower boundary, or the right boundary and the left boundary will change. Will the lower boundary and the upper boundary change or not change? Well, you will know. You can know that just by look at the difference and look at the multiplicity of these intersections. So in this case, all of them are multiplicity 1. That means the boundary will change. They'll change and change and change. Every time they cross a critical value or change the when you cross the intersection, the lower boundary and upper boundary will change in this case. So now let's set up here. So now what is it? The boundary region, y equals from -1 to 1, 0 to 1, and then from -1 to 0. So what we have is now this. So area. Wait, why do I have a sigma here? You know what? Why are the sigmas in all of the places? There must be like some hidden characters, which I did not realize when I typed in. I know that these sigmas are everywhere. Okay, sorry about this, but I guess I have to go back and see whether there's some hidden characters. Okay. And sometimes I cannot see them, but when I print, it kind of shows up, right? Anyway, so sorry about that. No, sigma is not part of it. Again, I didn't put the sigma because I like the sigma. It happens to be over there. So now here, right minus left. Integral y. Now, note that the slicing direction is now dy. dy. Don't mess up on this guy here. Area for area, it's easy. When you get to volume, you have to write this dy dx more. Okay. Now dy, y goes from 0 to 1. Y goes from 0 to 1, then what is the right boundary? The right boundary is gy, higher y value, higher y value, higher x value. So therefore, we have gy. That's the right boundary function minus the left boundary function. Now, plus the integral of dy, once again, dy. Y goes from -1 to 0. And what is the right boundary? The right boundary is now f of y. This is the right boundary function. And the left boundary function, they switch order. Yeah, they switch. And so this is now the integral. Okay, so any questions here? Any questions here?
Yeah, at the bottom of example 5, is that the final answer?
Well, this is not the final. You have to evaluate. You just have to evaluate the integral.
Okay, I see.
On the test, sometimes, I will ask you to go all the way until we get the number. That's what I do, if I don't specify. But sometimes I will only ask you to set up the integral. So let me tell you. On the test, you may have to go all the way until you simplify to a number. You have to go all the way. Now for this integral, you can easily go all the way. It's not hard. Integral is not hard. Okay. No, on the way. Sometimes I will ask you only for the setup integral. That is integral setup. Or is that clear? But if I do not give any specific instructions, then you have to go all the way. If I tell you that I only want the integral, get the integral only, then you set the integral. But that depends on the problem. Okay? That depends on how I will ask you the question. And sometimes if the curve is kind of ugly, then I don't want you to waste time, evaluating the integral, so I will just ask you for the setup. So it depends. Okay? Depends on how complicated the integral is and what other questions I can ask you. So it's all different. But again, no instruction, then that means you have to evaluate go all the way, and then you have to evaluate the integral. So do not assume anything. Follow the instructions. No instructions, then you must go all the way. Any questions here? Let's save this, clear this. Oh, by the way, let me now have this. How about do this here? How about if I now go to decimals here and let me show you. Let me see. Yeah, let me show the graph here. How about this? Where's the so here let me do I have to annotate? No, I'm not annotating. Here. Yeah, share. Okay. Now what I'm going to do is, you know what? The example 4, I didn't have a chance to show you, but let me show you how it looks like. So what I'm going to do is this. How about example 4 here? This is the equation we have. The equation we have is what? F of x is equal to x equals y plus 2. F of y is actually equal to y plus 2. And y plus 2 is this. And what is g of y? G of y is equal to what? X g of y equals y squared. You have this right here. G of y. Where's our y? Y squared. Y squared. There we go. Okay, so we have that. And then now, g of y, f of y. So how about now? Let's look at x here. So x here, can I? You know what? Did I show this here? You know what? How about this? Let me do this opposite here. Let me see. X equals y squared.
I got black beans to make burritos with.
How about let me show you this? Sorry. Let me show you the dx sizing. I think the dx sizing is a little bit easier, a little bit more interesting. So let me show you by dx sizing. So the fy is equal to what? Is equal to square root of x.
These pans. Oh, I'm sorry.
Look at him, he's looking at the window.
He likes it. We should put him this little bird hopping
And let me now show you g of x. G of x. Let me call this. What? Minus square root of x.
He doesn't
Minus
like him
square root
when
of
he
x.
touches his mommy too much.
No, he's looking at the window.
Then now
He
let me
thought
show you
this-
this.
oh,
So
there's a
what is this?
squirrel.
This is example. I'm trying to example
He
4.
thought
This
this
is
was a
y
bug.
plus x
He
minus
like lost his mind. He's like,
y plus x minus
climbing
2.
up the wall, and
Yeah.
I picked him up and went to sniff it, and he was like, oh,
We'll put you a mirror there.
Y plus what?
he thought
X
it was a
minus 2.
bug.
X minus
He
2. The
thought it
graph
was a
looks like
bug.
this. So this is how the graph looks like, right? So now what is the question here? Y is not between f of x and what? Now the question is, that's the upper boundary here. F of x equals this. I can now do that. So now what is the region? Oh, that region is empty. That's why it doesn't show. Wow, this is the region I see. Okay, so that's the region. And then how about that region right there?
This is what we like.
And okay, how about this? In order to find the region, what I need to do is I need to take maximum. Okay, so take the maximum of this. So f of x, and then instead of gx, all I need to do is take the minimum or the maximum of
Look at his eyes. Look at Seven's eyes.
maximum of g of x and k of x.
He's running
So you get this region right here.
Get this nut at him.
So this region right here, that's the area of the
nut.
question right there.
Wow, they're different.
And just color
They're
it.
different.
Now the max of g of x and k of x, because on this, if you look at when x is bigger, in case when x is bigger than 0, the green curve is higher than the blue
I
curve.
wonder are they
When
loud
x
or
is
is
less
it
than
as a
1,
call?
then the blue curve is
Loud
higher
these
than the
movies.
green curve.
He likes the squirrels
So
and
what I
the
do
rabbits
is,
better than the
for the
birds.
lower boundary,
He does.
it's
I
either
think he
going to be
likes them
g of x
all.
or k of x, but we take the higher one, and so as you can see, the equation changes here. So that's why when you cut into dx, I think we have 2 intervals. Okay, you can do the same thing by graphing in y2. Okay, you can plug in instead of fx equals square of x, you can say f of y is equal to y squared, and then you can graph the other one as well.
No, I do.
And now
need
should I
this
just
because
look
I got
at
spots on my
how about
nose.
this one? The third the example 5 now. Example 5, y is equal to y cubed. Sorry, x is equal to. What is this here? What did I do? Okay, this time I'm not going to do anything. Let me just write x is equal to x is equal to the y
It's
cubed
Windex on it. Windex. This
Just
solves
drop this.
everything.
plus y cubed and the what? The y is y cubed and the plus what? Plus y squared.
That
plus
actually
Y.
has Fabuloso in
Plus
it.
y.
too. So it should.
That's that curve. And then what is this one?
You mixed it in
This
there?
is the next one is x is equals to y squared plus 2y.
It looks
Y
like-
squared plus 2y.
I have glass cleaner in the
I'm not going to do anything with
so
this.
that
Oh,
right
it's
there
this
is
right here.
clean.
So this is how the graph looks like. This. This is how the graph looks like.
I know that the
Kind of
little
interesting.
pods has a spot cleaner built in. The Tide pods.
No, but I
things.
can't wash my
So, you know what? I'm not going to shade this region, but as you can see, there are the
Why
two
do you
regions
have to
right there.
run? You have to
And the
run.
intersections are y plus -1 and y plus 0 and y plus 1. Sense? So if I want to shade the region, then of course I need to call this f of y, but I already have an fy,
That's
so you know what?
something
There's not
Right,
much
yeah,
time
they
here.
have
So
it.
anyway, maybe I'll just stop here. So that was section 5.1 is now
different.
completed.
Nice like that.
Now okay, let me just open up the next section here, because tomorrow I'm going to go through the next section 5.2, and I don't know how much of 5.3 it looks like. 5.3 I cannot cover, so I will not be including 5.3, but 5.2 I will try to cover. The 5.2 is like a big section. It's the last day of class here, so again, I'm not sure, but I'll try to cover as much as possible, okay, for on section 5.2. So let me just open up here. Let me see. Can I open up the file? Okay, it's the share. New share is going to be this one here. This is section 5.1. 5.2, 5.2a, 5.2. Yeah, 5.2 is split into two sections, two parts. 5.2a and 5.2b. And here, let's see.
Let's see patients too.
Let me just wait for the section to pop up.
I think everybody is paranoid.
I just
Something
don't
slow
want to
here.
do it in the middle of the thing. I'd rather
That's
just
right.
wait until the next one.
Yeah.
Why is my file not popping up?
Deal.
Try again.
Maybe you have to do it.
File corrupted.
Do you want it on the oat bread or the
Try
sweet
again.
Hawaiian bread?
So when I try again, it pops up better.
With your BLT.
No, I'm not sure why it's not popping up. 5.2a. Not popping up. Did it already pop up? Up here? That's not that. Well, I'm not sure why it's not
Is the
popping up.
internet messing up still?
No, it's professor's here. I have this
Okay,
guy
you know what?
right now. I'm sure I'll ask for
And I will see what's in here.
Yeah,
The
he's
time's up
already.
here, so I guess
yeah.
I'll have to stop.
Go ahead.
So tomorrow is the last day of a Zoom meeting, and I will be going over section 5.2. The final exam will cover whatever I cover up to tomorrow's lecture. So if you have any questions, then bring it to me. And again, the final exam will be from 8 a.m. to 11 a.m. Okay, all of you have a good day then, a good day, and I will see you, I will meet you online tomorrow. Okay, bye everyone.
Thank you.
Professor,
Yes,
quick question.
what is the question?
Yeah, I emailed you again regarding my test questions because they were not uploading correctly, and I would like you to review the questions I had emailed you.
Well, okay, why don't you send me your email? You know, yesterday I did go through all the files. I must have missed yours. So why don't you shoot me an email, Canvas mail, and then also attach me all the files again, okay, just in case.
Okay.
Okay, just attach me all the files and tell me exactly what question, what test number it is, and so that I can check it again, okay, quickly. But
Okay.
make sure that the file has a timestamp with the time, yesterday
I
morning
will
or
attach
something.
as well the original email I sent you with the timestamp. It was during the time I was taking my test, so you'll be able to tell that it was towards the
Okay,
end.
please attach the file one more time or something so that I have access to your file immediately. But are you sure that I didn't go over? Because I did go over every file.
I know
which
this
was sent.
isn't. I don't know why but this isn't the first time you've missed my files when I sent them to you through email. So
Yeah.
I will just reach out to you again after class.
To Rachel.
Yeah.
So send me the files, and just tell me what it is, and then I'll look it up again. Okay, all right.
Okay. Thank you.
Okay, bye.
No.
The file DVI ultimately came up here. Now we can see 5.2a. So I don't know why it took so much. We'll go over this tomorrow. Okay, if anybody else has a question, I will be here to answer all of your questions.
Yeah, Professor, sorry. Do you have any recommendation on how we should study for the final? Like going over old test questions, is probably a good thing, but do you have any other recommendations?
Well, I think because you don't have that much time, I think at this time, what I want you to, I think the good thing is, yes, go over all the test questions, especially the ones you missed, and even the ones you didn't correct, I want you to look at the answer key and see whether that was the best way. So
Okay.
I want you to have an overall understanding. Also remember, when something pops up in the test, on the final, it is not likely that I will give you the exact same problem, but something similar might show up again. So make sure that you have an idea as to how you solve those types of problems. So you need to have a very clear idea.
And
Okay, so what also I recommend is, of course, I think I wrote down on the announcement one time, I want you to write your mini notes. So don't spend too much time reading solutions written by someone else. At this time, you must spend all your time, doing on your own, doing your own work, not reading solutions. So I want you to write mini notes and what? And let's just skim through. And then now at this stage, you have to make sure that you can do every problem. So you make sure that everything is absolutely clear to you. If something is less than clear, that means you have a problem here. So it's time that you have to have a very good understanding of everything. To write mini notes, and then so basically like go through the chapter, go through a test, go over test, and then go over like a chapter, and then go over notes. But if you have any kind of a chapter test on any textbook, you can go over that, and then notes. And then when you go over notes, then don't read the solutions. I want you to do the problems on your own. The key is spend time doing the problems on your own. Don't waste too much time reading solutions. Okay, that is not a good time. Okay, so that is not a good thing. So do problems, and then make sure that you can do it if the time is given to you. And write mini notes. Write what you know already. Write a mini textbook on your own. Write a mini textbook. So write what you know. Constantly write down what you know, rather than just reading books. Okay, reading pages. I want you to write down what you know, and this is very, very important. This will eventually, what you write is eventually what you know. What you know is what you write. What comes out is what you know. What goes in is not what you know. It kind of sounds like a Bible, but what goes in is not what you know. What comes out from you is what you know. So you have to be able. You should be able to write down what you know. If you cannot write down, that means you don't know. I'm sorry to say this, but if you cannot write down what you know, then that means you don't know. All right?
okay, no, I appreciate it. Thank you very much.
All right. Okay, so we'll have any more questions here? Huh? Oh, wait, which kind of questions? Claudia? Are you still there? Which kind of questions? Right. Okay, if you have no other questions, then I'm going to now shut down the Zoom meeting here. All of you have a good day, and I will see you tomorrow. Okay? Let's see, Summer and Jay are still there? Okay, if you have no questions, then I'm going to shut down the Zoom meeting. Bye. Bye, both of you. Bye.